Alright, today we're going to start chapter 6.3, talking about vectors. For now, we're going to start with equivalent directed line segments. It would serve you well to go ahead and read all the different vocabulary in section 6.3 to understand the words that we're talking about in this lesson. We'll do the best we can with the time we have. So we have two line segments, directed distance. Notice that the arrows indicate the terminal side, and the other point that's not has the arrow on it is the initial side. In order to be equivalent, the line segment must have the same magnitude and the same distance or same direction. For direction, we're going to use slope formula, which means their slope has to be the same. For magnitude, we're going to use distance formula, which means the distance formula has to be the same when you figure them out. So when I say this little two lines, then PQ, then two more vertical lines, these vertical lines mean the magnitude of PQ, and that's how we read that. So for PQ, to find the magnitude of PQ, which is line V here, gave that vector name of V, it's going to be the square root of 3 minus 0, and there should be a square right there, squared, plus the square root of 2 minus 0. I have that, I don't know what I'm doing. We already have a square root, and then 2 minus 0 squared, so that'll be 9 plus 4, so the magnitude is the square root of 13. Okay, now for the magnitude of RS, we're going to do the square root of x2 minus x1, so 4 minus 1 quantity squared, and then we're going to go 4 minus 2 quantity squared, and so that'll give us a total of 9 plus 4, which again is the square root of 13. They both have the same magnitude, so now let's check on the direction by using the slope formula. So for PQ, M equals y2 minus y1, so 2 minus 0 over 3 minus 0, because y is over x's, so the slope is 2/3. For RS, it's going to be 4 minus 2 on top of 4 minus 1, which is again 2/3. Since slope and magnitude match each other, we have just shown that these are equivalent directed line segments. Go ahead and try number 11 using the same concept. Okay, so the magnitude of U, and U is this top one because it has a U with it, is going to be the square root of 6 minus 2 squared plus 5 minus 4 squared, so it's going to be 16 plus 1, which is the square root of 17. For the magnitude of V, it's going to be the square root of 4 minus 0 plus 1 minus 0, and so that's also going to be the square root of 17. Now for their slopes, the slope of U would be 5 minus 4 over 6 minus 2, which is 1/4. And the slope of V is going to be 1 minus 0 over 4 minus 0, which is also 1/4. Therefore, these two vectors, vector U and vector V, are equivalent, have an equivalent directed distance.